full screen, madam? Is it full screen now?
Yes, sir.
Yes, sir.
Okay, fine. So the topic for today, differential statistics. So this is the most important part of any research. We start with the designing, title, objectives, aims, methodology, etc., etc. Finally, we'll end up. Now, after collecting the data, it has to be useful in the way which we planned before starting of the research. So here comes the role of statistics. Now, in this particular session, what is statistic in statistics? What's the difference between descriptive and inferential statistics? What are different inferential statistics? And what is the brief about inferential statistics and its importance? Here, let us see some popular quotes. Rex Stout had said that there are six, the kind you look up and the kind you make up. Means something which you just see and observe, which you try to make out. Another one is, do not put faith in what statistics say until you have carefully considered what they do not say. Means we just need not rely upon what the particular number is saying, but also look into it, what it really doesn't say or what it is hiding. And has said that torture the numbers and they will confess to anything. Means this is the usual practice. The moment we don't get collected data, we try to modify the data, we try to manipulate the data, and we torture these numbers to get our results. But keep these things in mind while we go through the presentation, because these things are very important, the basics of inferential statistics. So what is a statistic? Statistic is like we call something called as parameter. We call some parameter value that describes a population, and statistic is a value that describes a sample. That describes a sample is statistic. That describes a population is parameter, and it is the statistic is giving the actual psychology of the particular sample about the from which it is drawn. We usually have a confusion about the difference between what is mean by descriptive statistics and what is mean by inference. So descriptive statistics is the one in which we organize the data, we summarize, we try to simplify the data by various methodologies like presenting the data to make it more simple to understand by the layperson. These things are covered under descriptive statistics. Means the way in which it is descriptive statistics, whereas the inferential statistics is, now we have a sample. In any research, we always have access only to the sample. We hardly do a research or it is not feasible. So feasibility issue is there, and that is why we always take a sample, because sample requires less manpower, materials and resources. So sample is collected for any research, and we try to the inferences drawn from the sample to the population from which it has been drawn. So this generalization of inferences drawing from the sample to the population comes under inferential statistics. We go ahead testing our hypothesis. Now when we are doing any type of analytical research, what we do is we comparing two populations, comparing two samples, comparing two groups. Now this comparison happens at various variables. Now when we do this kind of tactic, we always have a pre-assumption or assumption in our mind that forward that the males might have more of this compared to females. The girls might have less of this compared to the semester 6th may be having better score than semester 3. These types of assumptions are tested as hypothesis testing. We also end up comparing two different variables, three different variables within a group, and so these predictions are the final outcome. And making predictions out of the data is nothing but statistics. So I'm pretty sure that you have now a clear understanding of what is mean by descriptive statistics, is mean by inferential statistics. So something which describes the data is descriptive statistics, and something which predicts inferences is inferential statistics. By and large, descriptive statistics is of three types. Density distributions, means here the subjects fall in a particular category. Second is graphical presentation. Second is graphical presentation in various forms, graphs, diagrams, box plots, and etc. Third is summary statistics, means you describe the data in just one number or try to describe it in few numbers. That is summary statistics. Now, frequency distribution is, say for example, you want to know how many males and how many females are in our class. You are displaying it with the help of the table, the numbers in this form. I have given an example. So males, last column is total, and then frequency, right? So this is another way categorize of more than one variable at a time, right? This is another example, how many brothers and sisters. So number of brothers, sisters, and another column you have frequency, you have proportions, percent. This is an example of graphical presentation like bar diagram. In that there are many other. This what we are looking forward is the descriptive statistics, the way it is presented, because understanding inferential statistics definitely, first of all, you should know what is mean by descriptive statistics. So histogram is another example, polygon. So the data is made simplified, data is made understandable, data is made more informative. This is of the graphs and tables, like here they are putting it across. We should also understand the descriptive statistics involves the central limit theorem, that the larger the sample, the closer the distribution. Similarly, a normal distribution, you all are aware that any given data sample more than 30 will follow a central limit theorem. That is why you can see, if you plot, say for example, 100 samples curve like this, in that the central value x bar is the average value, and on either side of it there is +1 and +1 standard deviation, -1, -2 and +2 standard deviations. So these are the standard with the mean, in which the number of percentage of the subjects values will fall into that particular limit. This we will understand a little more clearly in further slides. So this data takes a different shape depending on the values of the subjects parameters. So you may see distribution. Sometimes you see a bimodal distribution, sometimes positively skewed data, negatively skewed data. Now statistics, it describes the data in just two numbers. One number is the measure of central tendency, means typical average score, variability, a typical average variation. Now for quantitative data, we have mode, median. So mean, median, mode are under the quantitative data. And for qualitative, we have different, like mode usually we use, or mean hardly there is any scope for it. So mean is arithmetic average of the values. Median is the middle value of the data, 50% there on either side. And mode is the most frequently occurring observation out of the data. Most common and most useful average. Mean, to calculate mean, we have to sum up all the observations and the number of observations. And notation is x bar. Population notation is mu. Now there are properties for the mean. The sum of all observations as positive and negative deviations from the mean always equals to 0, and mean is affected by all values in the data set. So if you increase or with higher value, it is going to affect the mean. Now second one is the statistics that describes the data in just two numbers: measures of central tendency, typical average score, and measures of variability. So the measures of variations include a range, number one, that is the distance from the lowest to the highest value, the maximum value and minimum value. You try to see the difference between that is called as a range. Second is variance. Third is the standard deviation, and fourth one is standard error of mean. These things are very important to understand right from range. Range, we know that it's a difference between minimum maximum, and as we said, we are now here to understand what is mean by statistics. So descriptive statistics, we understood what is it. Under the measures of variability, we have secondly the variance is nothing but average of the distance that each score is from the mean. Means in short, it is referred as squared deviation from the mean. It is denoted by s square, and it is calculated by this formula. Second one is standard deviation, which is nothing but the square root of variance. So it is square root of s square, and standard error of mean is deviation divided by square root of the sample size. Square root of the sample size. Now coming to inferential statistics. Inferential statistics deals with the inferences drawn from the sample and generalized to from which the sample has been drawn. So this is in short the drawing conclusions, drawing inferences about from a smaller sample size, sample group. Now while dealing and while doing so, we come across various is called as sampling error. Now what we have drawn as a way. Hello, hello, hello.
Hello, participants, please.
Mute yourself, participants.
Now,
Please
whatever
mute.
conclusion we draw from a sample may or may not be generalizable due to various reasons. Reliability is nothing but how much we can generalize particular conclusion to a larger population. So reliability includes the sampling error, variability among the samples due to chance versus population. Means whether the result is real or just by chance. To understand this, we need to understand few more things. First is probability, the numerical indication of how likely it is that a given event will occur. General definition. Statistical probability, the odds that what we observed in the sample did not occur because of error. Or in other words, we can say probability associated with a statistic is the level of confidence we have that the sample group that we measured actually represents the total population. In a nutshell, what it wants to say is if you are working on a sample, the sample should be a representative sample of the population. The more it represents to a population, the more reliable your results are. So in short, what we are looking forward is to have a representative sample to draw the best inferences and best conclusions for a given population. Now here it comes what exactly it. So we have to understand the chain of reasoning for statistics. Like we draw a sample from the population, means we select a sample and then we measure the data. We measure, here it is, and then with probabilities we are drawing inferences and we are generalization. So this is the cycle. Now here the question comes whether my inferences are valid or not. Now with what validity it is valid and with what probability that I am pretty sure that it is inferences applicable to the population. In other words, the generalization of the conclusions based on the sample which has been drawn out of the greater. We draw a sample from the big population, we hypothesize few things, few assumptions, we try to test. After that we reject few, we accept few, and then we draw conclusions, and these conclusions are and generalized to a larger population. So this process is nothing but the statistical drawn from a sample. Now here it comes the preparation. Now hypothesis preparation depends upon with what efforts you have done the basic researches. For hypothesizing about any population, we need to have the basic data in our hand. Now our basic data, which is usually in the form of observational studies. Now through observational studies we collect basic data, and understanding and examining the basic data we try to hypothesize. So generation of hypothesis is by the lower level studies, and testing of hypothesis is by the higher level studies or higher hierarchy studies like analytical studies and experimental studies. So we want to draw a conclusion parameter. Say for example, in a population of women who use oral contraceptives, is the mean change in 0 or not? Means females who are using oral contraceptives, other group who is not contraceptives, if we try to compare these two groups, my hypothesis is that there is a or increase in the blood pressure among the women using oral contraceptives. Now to test this, I need to group which is not using oral contraceptives, right? Now hypothesis testing is when you have you are comparing two groups, you have to assume that there is no difference in the group. Means change in blood pressure not happening in the group using oral contraceptives as well as in the group not using the oral contraceptives. This is like the difference in the mean blood pressure of those using oral contraceptives and oral contraceptives is 0. This is the notation of the null hypothesis is referred by H0 and alternative hypothesis by HA. Now mu the blood pressure in both the groups. We reject H0 if mu is far away from the 0. Right? Now we are testing both hypotheses at the same time. So our results will also use to either null hypothesis or fail to reject null hypothesis. We either reject it or we fail to reject it. Or in words, either we reject null hypothesis or we accept null hypothesis. Fail to reject null hypothesis is hypothesis. Now to understand this a little more, say for example, null hypothesis is value that the null means there is no difference. Incidence of low birth weight among smokers minus incidence among non-smokers is means we are trying to test or assess whether there is any increase in the incidence of low birth weight among smokers non-smokers. So null hypothesis is incidence of low birth weight among smokers minus incidence among non-smokers to 0. Now then, what do we mean by alternate hypothesis? It is consistent with wide range of values, range from small value to a large effect. Means incidence of low birth weight among smokers minus incidence of incident among non-smokers may range from minus infinity to plus infinity. It can have any number from one end to the other end. Right? Are you getting my point? So hence falsifying null is easier. Reject null hypothesis. Why we never reject alternate hypothesis? We reject null hypothesis because it is very easier. It is very reject null rather than rejecting alternate hypothesis, because alternate hypothesis takes any value ranging to infinity on two extremes, whereas null understands only one value, that there is no difference. So you reject null will automatically get the alternate hypothesis accepted. So this is the basis of inferential statistics. We prepare our hypothesis and we prepare the null hypothesis and we try to reject the null hypothesis. Null hypothesis, in other words, is automatically accepting the alternate hypothesis or a research hypothesis. So hypothesis is like, do our sample results allow us to reject null in favor of H0? Means maybe we got a big sample mean of from chance occurrence, and maybe H0 is true and we just got an unusual sample. Sometimes it happens. In other words, do our sample results allow us to reject null hypothesis in favor of alternative hypothesis? So what is the probability on such extreme sample mean as 4.8 if the null hypothesis was true? This probability is called as p-value. We know that the given difference occurred, or given difference in the incidence occurred of a real difference or because of a chance. So to understand that, we need to understand the sampling distribution. Now sampling distribution of the sample mean is the distribution of all possible values of examples of the same size. Means you take different samples of the same size and try to see where the average lies. Right? Now the sampling distribution is centered around at the truth value, which is equal value. And in hypothesis testing, we start under the assumption that H0 is true. We always start with saying that there is no difference in the two groups. But finally, we reject our hypothesis, that is null hypothesis. That there is no is rejected, means there is a difference is accepted. Now getting p-value, to compute a p-value, we need to find our value of x bar and figure out how unusual it is with population. You draw a sample from the population, try to find out the average of the sample and try to see how far it is close to the population mean or it is far away from the population mean. This is the way we use to get the p-value. P-value, we would need to compute the probability of moving a particular value or more standard errors away from the. These things we will try to understand later in the subsequent slides, how in relation with standard deviation and standard error of mean we use to calculate our p-value. Now how can we make the usefulness of p-value? Say for example, the arbitrary cutoff for p-value is 0.05. This is an arbitrary value and the cutoff is called as alpha level test. Now at this particular cutoff 0.05, if the value of our result 0.05, then we reject the null hypothesis, means we are going to accept the research hypothesis. If the p-value is more than 0.05, then we accept the null hypothesis. We accept that there is no difference in this, and we ultimately say that there is absolutely, the groups are not different, they are same. Right? So this, I believe, in simple words, p-value less than 0.05 is a significant value. P-value more than 0.0 non-significant value. Significant value means we are rejecting the null hypothesis. Non-significant, we are accepting the null hypothesis. Here, look at here. This is an example of how p-value if the null hypothesis is true. So 8 out of 100 such trials, it would show 66% because the risk ratio here calculated is 33. So the reduction, now it is the RR is there is a reduction. So 66% or more extreme just by chance. So here 8 out of 100 is calculated or estimated from the p-value. P-value stands here is 0.08. Right? Secondly, 70 out of 100 such trials would show a risk reduction of 17% or more extreme by just very unlikely a chance finding. Now out of these three, 0.7 and 0.007, these two values are non-significant. Means we can say that in these two scenarios, difference which has occurred is by chance. And here, in this case, it is less than 0.05. highly significant. Means there is unlikely that the difference occurred is by chance. So it is by difference, not by chance difference. I hope you are getting. Now, understanding p-value alone is not enough. We need to understand the confidence interval provided by. Now, why it is important? What are the lacunae of p-value? P-value cannot show you the strength of association. You cannot say with this strength my result is significant. P-value cannot show you the direction, in which direction it is, whether it is increasing, less, more. P-value is not a precision parameter. Means precision of the point estimate is not shown by. Now, from where do we get these things? These things are possible only through calculating the confidence interval. Confidence interval. So magnitude of the effect means strength of association is given by confidence interval. The direction of relative risk more than 1 or less than 1, if it is there, it is shown by only and only the confidence interval. Of the point estimate of the effect means variability is given by the confidence interval. These things, p-value cannot prove all these three important things. And our results are always including these things. We always the strength of our association, what is the relative risk, what is the odds ratio, how much our value or how much precise is. These things are important when we discuss a very important result. Important result cannot if it is mere percentages and proportions or averages. Averages, percentages, proportions are not enough. Results are more significant. The significance is shown only when you can prove that this is the strength of my association of these two. This is the relative risk, this is the odds ratio, and this is the precision of my point estimate. Unless and until you show these things are not supposed to be that much strong. So inferential statistics, it uses the sample data to evaluate the credibility of the hypothesis about a population. So we start with the null hypothesis. Null means it's a Latin any, means no. There is no difference between the means of two groups. It is usually shown by H0 mu1 equal to mu2, means these are two averages and both are same. So we always H, that is referred as H naught. So we always test the null hypothesis. As I told you initially, testing null hypothesis, because falsifying the null is easier than falsifying the alternate hypothesis, because alternate hypothesis takes so many values, possibility of taking the value right from minus infinity to plus infinity. So there is a wide range of values which alternate hypothesis, but then null hypothesis takes only one value, that is 0, and that is why rejecting null hypothesis means rejecting this is easier than rejecting alternate hypothesis. That there is a difference. So scientific or alternative hypothesis, it predicts that there are differences between the groups. Alternate hypothesis, there is a difference. Null hypothesis says that there is no difference between the two groups, right? So what hypothesis? Null hypothesis is like the two groups will not differ. Means there is no difference in the two groups. Alternate hypothesis, group A will do better than group B, or group A will not perform the same as group B. This is alternate hypothesis. So I hope you understand what is meant by null hypothesis and what is meant by alternate hypothesis. hypothesis. So when making comparisons between two sample means there are one possibility is null hypothesis is true, means there is no difference, both the groups are same. Second hypothesis is null hypothesis is false, means it is false to say that there is no difference. Ultimately we are rejecting the null hypothesis. In case of null hypothesis is false, and we are not rejecting the null hypothesis is true. So try to understand these two possibilities. In any research comparison, we have two possibilities. Null hypothesis may be either true or null hypothesis may be false. When the null hypothesis is true, it means we are not rejecting the null hypothesis. This false means rejecting the null hypothesis. In short, these two things you need to understand very clearly. Now, the possible outcomes in hypothesis testing means decision tree. This is a decision tree. When the null is true, we should get it accordingly, right? Then we have to accept the null. When the research says your hypothesis says there is no difference, when both these two are combined and you are getting appropriately, when there is means there is a difference, there is no difference, and through research you are not getting difference, it is null is false, means it is false, that means there is a difference in reality, but you are accepting null, means you are accepting that there is no difference. It's an error that is referred as type 2 error. When there is no difference but you are rejecting the no difference, it is committing type 1 error. When there is no difference and through research you have not obtained any there is a correct decision. So by and large, try to understand that there are two types of errors, type 1 error and type 1 error is rejecting a null hypothesis when it is true, and type 2 error is accepting the false hypothesis, accepting the null hypothesis when there is a false hypothesis. Are you getting my point? Type 1 error and type 2 error. So hypothesis testing, whether the decision is right or wrong, this happens when you are balancing the type 1 error and type 2 error. When you are balancing type 2 error, as referred earlier, type 1 error and type 2 error. Now to understand how to balance this type 1, we need to understand the various parameters. Now here we have referred as type 1 error. This is alpha level. Now alpha level is what? The probability of making a type 1 error, means it depends on the criteria on reject the null hypothesis, that is significance level. Means this is the cutoff beyond which you will take the result as by chance, you will take the result as by a real difference. So 5% level, this is nothing but 0.05% level. So 5% level of the type 1 error means 5 chances in 100 that result was really due to sampling error. 5% of the time a type 1 error will occur. So when 100 samples, you will allow to take the sample difference by chance not more than 5%. 100 maximum you can accept the difference by chance only by in 5 samples. not only in 5, not more than that. So difference observed here is really just sampling error. Means by doing is we are assuming that the difference observed so is just by chance, not by, is just by sampling error, not by the real difference. So alpha level is nothing but the probability of committing error referred by alpha. So when we do statistical analysis, if alpha means p-value 0.05, we accept the null hypothesis. And when doing the statistical analysis, if the level of p-value is equal to or less than 0.05, we reject the null hypothesis, difference between means, right? So this is a very simplified thing to understand. If you have a question, you can ask at the end of the. Now 5% reason of rejection of null hypothesis is non-directional, means on either side 2.5% here and 2.5% on the left of the mean value. So 5% reason of rejection is null, whereas 5% reason of rejection in this case is unidirectional, means in one way. Sometimes we test a drug and our assumption is, I don't know whether it is decreasing the BP or increasing. At that time it is to tell. But when you say or when you claim that the drug is going to decrease the blood pressure, so it is like that, you are taking the one-tail rejection hypothesis. Try to understand what is mean by two-tailed and one-tailed. Second thing is, after alpha, we need to understand beta. So probability of making type 2 error. Alpha is probability of making type 1 error. Beta is probability of making type 2 error. Error is what? It occurs when we fail to reject the null when we should have rejected the null. Hello, sir. Good morning. Congratulations. Congratulations. Thank you. Definitely, sir. Yes, sir. So we have planned at 30, sir. Yes. No. We have intimated secretary and all. Yes. No. Yes. Yes. Yes, sir. Yes, sir. We'll do it, sir. We have a plan for execution. Yes, sir. We'll discuss. I'm attending one webinar, sir. No, I'll call you, sir. Once I finish, I'll call you back. Okay. So the value of beta means the probability of making type 2 error. So look at the chart again. Here null hypothesis it is accepted, null hypothesis is false and accepted. Similarly, there is a null hypothesis, means no difference, and you are rejecting it. You are committing. The null hypothesis means null is false, means there is a difference, but you are accepting null hypothesis, means you are accepting that there is no, so you are committing type 2 error. So these two things, out of that, type 1 we have already understood what it is. Type 2 is beta error. Difference observed is real, failed to reject the null hypothesis, right? Now beta, in other words, is also the power, means ability to reduce type 2 error is nothing but power of the study. Ability to reduce the type 2 error is nothing but power. And by and large, in all practical, for all practical purposes, we take the study power as The study power as 80%. Means our study should have power of minimum of 80%. Right? But ability to reduce the type 2 error means the power to find an effect if an effect is present. So how to study? We can increase the size and thereby we can increase the power. We can decrease the variability, means by decreasing variations among the variables, we can increase the power of the study and take more precise measurements, increase the power of the study. Effect size is nothing but measure of the size of the difference between means attributed to the treatment. Means the average of, say for example, you are testing the efficacy of a drug, whether it is decreasing BP or not. So difference average of blood pressure in test group minus average of the blood pressure in control group, that will give you the effect. Now, before going further, means while going further, we need to understand various measures. Thereby, we are using the data and we are interpreting it in different useful way. Useful way includes estimating the relative risk if it is there, estimating the odds ratio if it is there, the attributable risk, estimating the attributable risk proportion, and finally the population attributable risk are important, and these are nothing but the major part of the inferential statistics. So absolute risk is among mothers who smoke, 5% mothers, right? So relative risk is risk among mothers who smoke, means who are exposed, which is equal to 5%. Risk of low birth weight among mothers who did not smoke, on extent, is incidence among exposed divided by incidence among non-exposed. So it is because 5% divided by 2% is 2.5%. This is a relative risk. The risk of low births who smoke is 2.5 times that among those who did not smoke. So this is the interpretation of relative risk. Attributable fraction. Many times in your research, you would like to know what proportion of low birth is attributed to the maternal smoking itself. Sometimes you would like to know what proportion of low birth weight could be avoided by maternal smoking. And further, is smoking during pregnancy was declared punishable by law? What of LBWs would be averted in Pondicherry? So these kinds of questions will be answered only if you go by statistical analysis, and that too inferential statistics. Like take the example of smoking during and development of low birth weight and non-development of low birth weight. And here there is a total. So here these people are exposed to not exposed to smoking during their pregnancy. So there are 75 such who have out of 75, 27 developed low birth weight. Those who did not expose to smoking were 81%. Out of 81, 14 developed low birth weight, 67 without low birth weight. So likewise, this data is given. So here we calculate birth weight among mothers who smoke. So it is 27 divided by 75.36. Low birth weight among mothers who did not smoke, it is 0.172, and the relative risk is 2.1. So there is a 2 times higher risk of development of low birth weight if the mother smoke during pregnancy compared to smoke during pregnancy. Attributable risk fraction This attributable risk fraction is given by incidence exposed minus incidence among non-exposed divided by incidence among exposed. So here we go, it is calculated as 52.3%. Difference is 52.3% of low birth weight among smoking mothers was due to their smoking habit. Attributable risk among population is you need to have the incidence among population. So if you know the incidence, thereby you can calculate the population attributable risk. So here it is calculated as 35%. So if we stop smoking, how much proportion of low birth weight will be averted in population? So it is 35% here. Coming to the odds, what do we know by odds? So probability and odds. Try to understand the difference between probability and probability is what? The desired divided by the total, means proportion. It is numerator is a part of the denominator. Means what you have desired upon how much was the total. This is probability. But odds is desired against undesired. So it is a ratio. The numerator is not a part of the denominator in case, whereas numerator is a part of the denominator in case of probability, right? So desired upon total is probability, but desired upon odds. So odds of smoking among low birth weight from the previous table is given by 14. So look at the table again, 27 upon 14. So those who smoke, this is the odds of smoking among the low birth of smoking among the low birth weight, no low birth weight, odds of low birth weight amongst, right? Likewise you have to calculate. Now then we can calculate the exposure OR and disease OR. Now odds ratio and relative risk, they become equal, approximate each other when the incidence of, means if the incidence is less than 10%, you can very well say that odds are same as relative risk, means odds ratio is same as almost relative risk. So the significance testing is practical versus statistical significance. Like depending on, now it's a lengthy thing and it may, our time may not permit us to include everything. A brief of what is what. So first of all, for inferential statistic, you should know what are the different levels of measurement of data. Levels of measurement of data includes nominal measurement, ordinal measurement, then there is interval and ratio. There are 4 levels of measurement: nominal, ordinal, interval and ratio. Nominal is one like categories, color, then religion. It has no relation with each other, right? There can be a car of black color, red color, silver color, right? It's name of the category, male, female, right? Hindu, Muslim, Christian, right? These are ordinal data like mild, moderate, severe. Means there is little difference, but that difference among the categories. We don't know whether difference between moderate and mild is equal to severe and moderate, right? Specificity. Further, this are interval and ratio. So out of these, discrete data and continuous data. Now discrete data includes ordinal, nominal, ordinal, and continuous data includes interval and ratio. Means there is no absolute zero in the other. These are interval and ratio. So interval ratio usually is referred as parametric data. Ordinal are usually referred as non-parametric data. So for parametric data, we have different tests of significance. Parametric, we have different sets of test of significance. Now, test of significance, say for example, you can say that there is a difference between a male and a female. If you have been shown two people, or if you have been given horse and one dog, and if somebody is asking you whether there is a difference between dog and horse, so it is very obvious there is a difference between a dog and a horse because of their structure, because of their appearance, and many other things. So the difference in your eyes, you can very well observe the difference. But if there is a question like you are going to Chennai, and whether there is a difference in the average height of trees on your left side compared to trees on your right side, try to understand. You are reaching some city and you are crossing a road, you are traveling on a road, and if somebody is asking you, there is a difference in the average height of trees on your left side compared to trees on your right side. Now both sides, in earlier example there was a difference between dog and horse. It is very obvious, right? But things are same, trees, and the average height of tree difference has been asked, right? Now you are in a confusion. In this scenario, you need to apply a test of significance. But in the earlier case, there is no need to apply a test of significance. Significance is applied when there is a confusion, when there is no surety, isn't it? When everything looks similar, but you still try to assess the difference, at that time you need to apply a test of significance. Now, application of test of significance depends on what type of data you have, whether it is a non-parametric or parametric. Now, for non-parametric, we have a set of tests like Z-test, Man-Whitney, etc., depending on the data. When you have a parametric data, different sets of tests like t-test, independent t-test, right? Paired t-test, ANOVA test. So t-test experiments include only two groups, independent or correlated. Correlated is either within subjects. So based on the t-statistic, we either reject the null hypothesis or accept the null hypothesis, p-value obtained from the statistic calculated. Analysis of variance, when you are comparing more than, you need to use the analysis of variance. Here F statistic, critical value is calculated, and depending on the alpha level and degree of freedom and the p-value, we used to say whether the difference is there or not. And there is something which allows statistical averaging of results from independent studies of the same phenomenon. Now, by and large, depending on the distribution, depending on the hypothesis testing and number of samples, how many groups you have, that test when you have a single sample group and when the distribution of mean is normally distributed. If you have t-test, yes, single sample t-test can be applied when you have one group. Z-test is in relation with the population, relation with the sample. Paired sample test when you have two groups, same participants, distribution of mean difference. And independent samples test, t-test is used when you have two groups but different participants, means you use independent sample t-test when the groups are of the same participants, when the measurements are from the same of before and after time, you use paired t-test. In short, comparing means Now comparing means maybe between groups. Comparing means measurements maybe within the same subject. Now when we are comparing and having two groups, you use independent t-test. When you are comparing between two but with more than three groups, you use one-way ANOVA. When you are comparing measurements means same subjects having two groups, paired t-test. When you are comparing measurements within the same subjects having more than three groups, you use repeated measures ANOVA. ANOVA stands for analysis of variance. So in short, the question is what you are comparing and between how many number of groups. It all depends on that. Use independent t-test, paired t-test, ANOVA test, one-way ANOVA, multiple ANOVA. All that depends upon the comparison is within groups, between groups, same subjects, different subjects, two groups, or more than two groups. So here we would like to go for one exercise. The exercise is the average weight of the population A is 72 grams. Try to understand this. The average weight of the population of town A is 72 grams. 100 subjects were randomly selected from town B and their weights were measured. Their weights are as follows. Like here there are some from 56, 72 up to 49. Now what we want to know is there any significant difference between the two? Means here they are comparing two towns, town A and town B. Town A, the average is 50%. Town B, they have given 100 measurements and they have asked whether the two towns the average or different in average. They have added one sentence, assume data follows normal distribution. So when you do any inferential statistics, first of all, you have to verify and ensure that the data follows and for following, whether it is following or not, you can use different tests. There is case test, Kolmogorov, there is Sharpio test to test whether the data follows normal distribution or not. After testing that the follows a normal distribution, only then you can go for testing hypothesis, applying different statistical tests. It is applied only and only if the data follows normal distribution, right? Now it's very simple, but we should not get confused by what they are asking, right? So the first question which mind is, what is the aim? The aim is to compare one group mean to a hypothetical mean value. This question that should come to your mind is what type of data it is. Now weight is a ratio data. Whether the data follows the normal distribution or not. If yes, you follow one sample t-test. You follow one sample t-test. It is simple, right? And I believe it is simple, but the right question should click your mind. You should try to understand what the aim is. The aim is to compare one group mean to a hypothetical mean. Hypothetical given is 72 gram percent. The other mean we have to calculate from the 100 sample data given. Question is what type of data it is. Now you have to look what measurement they have given. Now it is a weight. Now weight is a continuous variable. Weight is a continuous variable. So it is a ratio type of data, not interval. Whether the data follows the normal distribution or not. Yes, they have already given, assume the data follows normal distribution. So all answered, Now, if your answers are in this fashion, you have to apply one sample t-test. Means when you have been given one, for which you need to assess the average and compare it with one hypothetical value where the parameter follows, you use one sample t-test. Second example, two groups of diabetic people were selected for the study. For one group, metformin was given, and for the other group, new drug was given. Right? Sugar levels at the end of 2 months are as follows. Which drug is better in reducing the blood sugar level? Now here there are two groups. One group was given metformin drug, other group was given a new drug, and they have the blood sugar level in metformin group and blood sugar level in new drug group. So the is given for all the subjects in both the groups, and the question they have asked is which drug is reducing the blood sugar level. In this case, what do I do? Which type of test I should apply? Now let us go by. The first question should be, what is the aim? The aim is to compare two unpaired groups. These two groups, one group is independent of the other group. There are two groups. One group is getting metformin, other group is getting new drug. Second question should come in your mind is what type of data it is. Blood sugar is a ratio data. Blood sugar is a ratio data. The third question should come as whether it is following a normal distribution. The blood sugar being a normal, ratio type of data, it follows a normal distribution, or else we will test it by the normal distribution tests. So when you have two unpaired groups, you use unpaired t-test or independent t-test. Third exercise is, say for example, systolic blood pressure of 10 hypertensive individuals who had been being recommended. They were administered 2 ml of antihypertensive drug through parenteral route and BP is recorded again. Did the injection of new drug? Now BP before injection is given, BP after injection is given. Right? So a drug is tested to subjects, but before injection BP is calculated, after injection BP is calculated, and now we want to know whether really had decreased the blood pressure or not. So likewise, first is what is the aim? To compare two paired groups. Why paired groups? Because the same subjects were given, means the measurement was taken from the before giving the injection and after giving the injection. So it is a comparison between two paired groups. Now what type of data it is? And third question, whether it follows normal distribution or not. Yes, it is following normal distribution. You better go for paired t-test. Right? So I hope you understood what exactly is the understanding between statistics and inferential statistics. What do we do in inferential statistics? The different modalities, how to calculate odds, how to interpret it, and depending on the number of groups and type of data, what type of test we need to apply, in which circumstances which particular test is utilized. This we have covered up. There is, or a researcher wants to see the effect of 4 new herbs on a hemoglobin level. So she selected 7 subjects. A fixed dose of 4 herbs is given to the respective group for 1 month. Is there any significant difference in the hemoglobin level between the groups? Follow normal distribution. So researcher wants to see the effect of 4 new herbs. She had taken 4 new herbs and she wants to know change in hemoglobin level among 7 subjects in each group, right? So here the data is given: subject 1, 2, 3, 4, 5, 6, 7, herb A, herb B, and herb D. A, B, C, and D. 4 types of herbs were given, and from all these 7 subjects, hemoglobin level was estimated. Now we want to know, what is the question? Is there any significant difference in the hemoglobin level in the subjects? So whether there is any difference in average hemoglobin among the 7 subjects across 4 different hubs. So how to do that? What is the aim? The aim is to compare 3 or more unmatched groups. What type of data? The data is hemoglobin, which is a ratio type of data, and they have already mentioned normal distribution. So you can go for one way ANOVA. Here I would like to tell you that inferential statistics is the most important part of any research, because deals with that more so, and all your prepared objectives of any research actually trying to assume something, compare something between two groups, right? And these things are obtained only if you have the good quality data. Now good quality data, the good quality data has to be converted into appropriate descriptive statistics and inferential statistics. Unless and until you quality descriptive statistics and inferential statistics, you cannot present your research findings appropriately. So the are solely depend upon how best you calculate the descriptive statistics and inferential statistics. Drawn should be generalizable to the population, and these things are very important, and these things are important in the sense the comparison of two different research literatures or two different research is always based on findings you are